Hello, everybody. It's me, Mr. Promo. I'm going to talk to you today about complex fractions. I'm not with you today because I have to be at the district office for some planning meeting that doesn't matter. Who cares? Okay. What we're going to learn about today is complex fractions. Your homework assignment tonight is only 7.2b. We skipped this last time. It is the worksheet 2, and you're doing 1 through 7 odds. We will not have to go back and do any of the problems out of the book. If you understand how to do this, you will be fine for complex fractions. Okay? So let's take a look at what a complex fraction looks like. This is what a complex fraction looks like. I can even see the dots on that thing. That's pretty good zoom. And I don't know if you can see, but I have some white out there where I whited out the stuff there. So this is a complex fraction. A complex fraction is where you have a fraction over a fraction. In Algebra 2 and in higher level mathematics, you cannot leave your answers with complex fractions. So it's the one thing you need to learn how to do that you will use for those of you moving on into advanced math next year. You will have to know how to clear complex fractions. A fraction over a fraction. It looks like it's hard or confusing. These look very, very intimidating, but if you've ever heard of, oh, he's just a big old teddy bear, that's what these are. These are just big old teddy bears. What you need to do is you need to figure out what the common denominator is of each of these little fractions. So when I look at the bottom here, and I have a 5x in this little denominator, and I look at this denominator, and it's a 10, and I look at this denominator, it's a 10x, and this denominator, it's a 5, I need to figure out what is the common denominator of all of the little denominators. What can these all go into? So the first thing I need to figure out is what is my LCD, which stands for lowest common denominator. 5 can go into 10, 10 can go into 10, but I have an x, so I'm going to need, hopefully you see, a 10x. What do we do with this LCD? We're going to put it next to each of these little fractions. I'm going to multiply the entire top thing by 10x, and I'm going to multiply the entire bottom thing by 10x. Don't make fun of my pink pin. So 5x goes into 10x. 5x goes into 10x. See how this is going to cancel? The reason why I put it next to each term, one, because I have to, but the reason why I do that is so that I can see, hopefully, these little denominators will all cancel out. Can 5 go into 10? How many times? Can x go into x? 1 time. What's left right here? I have 2 times 2. And I just simplify that, and that would make 4. For this piece here, that makes 4. There is no more little fraction over here. I'm going to do the same thing here. Does this 10? Instead of doing the multiply first, let's do the divide part first. Instead of multiplying by 3 times 10, I'm going to do 10 divided by 10. I could do this in any order, so I can do 10 divided by 10 one time. What's left? 3 times x. See how simple that is? 3 times x is 3x. But I'm forgetting something. What am I forgetting? Oh yeah, it's married. It has a wedding ring. You remember that stuff? Don't go after married people. It's good advice. What else? 10x, 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 10x. 1 time. 1 times 3. 3. The bottom left is now a 3. I'm going to put a little line here so I don't get you confused. Did I put the 10x right there? 5 goes into the 10x. How many times? 2. 1 times 2x is plus 2x. So this whole thing simplifies to 4 plus 3x over 3 plus 2x. I would do that. I would look to see, can I factor this? Can I simplify? Can I do these x's? No, they're married. Don't forget. But you should check to see if this is factored or not. And that, my friends, is the correct answer. 4 plus 3x over 3 plus 2x. We've taken it from something that has fractions over fractions to now down to a single or a binomial over a binomial. It's basically going from 1, 2, 3, 4 layers down to 2 layers. Make sense? We're going from a 4-layer cake down to a 2. And I know some of you want that 4-layer cake, but in math you cannot have the 4-layer cake and eat it too. I'm on fire today. All right, looking on. Let's go to the next example. So, I'm going to show you this one, and then I'm going to give you a chance to do one on your own, and we'll have 2 videos today. So, looking at this one, what's my LCD? Oh, let me zoom out just a bit. I know some of you like to read those directions, so I'm going to put those there. First thing I do is find the LCD. What's the LCD? Let's see, 6 and 3. 3 can go into 6. 6 can go into, 5. 5 can't go. I look at all these denominators. Let me underline them so you know. I'm looking at all the little denominators. 3 goes into 6. Well, 6 can go in, can't go into 10, but 6 can go into 60. Is there a smaller one? 5 can go into 60. Can 5 go into 30? Can they all go into 30? There's our LCD. How about 30? What do I do with it? Multiply each numerator by the LCD. So here's the numerator to that one. 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 Technically, what we are doing is we're multiplying by 30 over 30 to everything. Technically, what is this number? This is 30 divided by 30 is 1. Technically, we're multiplying by 1, which is the reason why we can do this. We can do it because anything times 1 is itself. Now that I've said that, see how this little denominator 6? We'll do the division first. 30 divided by 6 is 5. What am I left with? 5x. 3 goes into the 30 10 times. What am I left with? Oh, don't forget this. This is a minus sign. Subtract 10x over. Do the division first. 5 goes into 30 6 times. I have 6x. 10 goes into 30 3 times. I'm left with negative 21. Now, you never stop when you get here. You only stop if there's nothing else you can do. What can I do? Can I put these two things together? Are these like terms? Are they homies? Can you put them together? Do they come from the same block? The other day I said in one of my classes, I said, they're both from Tarpey. They're homies. They can hang out together, right? There you go. 5x minus 10x is negative 5x. Can I factor out anything here? How about a 3? 2x minus 7. The reason why I do that is to see if anything can cancel. Because right now we can't do any of this stuff because they're married or they're in a relationship. This I can't do. So this is my final answer. Always leave it in factored form. Make sense? Okay. So here's the problem I want you to try. You can try this one. It's a little bit harder for you to do. I'm going to cover up this one right there because I don't want you to do that one. I'm just going to show you that for kicks and giggles.